Hey guys, so you got your quiz on Monday, so I figured I'd go through this review guide. I got through a lot of it in class, but not all of it, so it seems like a good thing to go ahead and finish it off. So I don't think there's too many people that had any questions about this stuff, but we'll run through it again anyway. It says find the line segment that's congruent to ON, and remember all you got to do is look at the congruence statement. And so ON are the middle two letters in this name. So it's got to be congruent to the other thing that's the middle two letters in the other name. That's it. You just grab the IR, and ON must be congruent to IR. That's how congruent statements work, is everything that corresponds is in the same place in the name. So for angle R then, that's the third letter, so it must be congruent to angle N because that's the third letter. And IB is what? Second and first, so that must be congruent to OS. Order does matter, so make sure you say OS, nothing else. And then angle RBD or RDB is third, fourth, first. So third, fourth, first is NGS. And DR is fourth and third, so GN. And then the measure of angle S, S is first, so B is first. So it'll be the measure of angle B. And that's it for those. Those should be easy. This is just some vocabulary. It says if the preimage of a figure can be mapped onto the image through one or a series of rigid transformations. Then the preimage and the image are congruent. That's it. That's the definition of a rigid transformation. Is that if you can, when you do a rigid transformation, the image will always be congruent to the preimage. All right, here you're supposed to be describing a transformation that could map these figures onto each other. So you're starting here at the preimage, and you want to map this thing all the way over to the image over here. So you'll start here, and you'll want to map it onto this triangle. So 1 maps onto 2, then 2 maps onto 3, and then 3 wants to map onto 4. So we'll do that in 3 separate movements. And so the first one is a 180-degree rotation around point F. The next one that will map triangle 2 onto triangle 3 is a reflection over line XY. And I guess you could write line XY, but I don't know why I'm doing that. You just say XY and you put the correct hat on top of it. So you say XY, put a hat on it. Then you want to take triangle 3 and map it onto triangle 4. So that's going to be a translation up. And it's going to be up a distance equal to the length of RK. So we'll say translation up. And we could just say along segment RK. And we would know that we should start at R and stop when we get to K, and that would be the right movement. Now they're asking us who is triangle DEF congruent to. And so for that, again, we have to make sure everything corresponds. So for angle D here, if we do that rotation, we're going to spin around and coincide with this angle. Then we reflect and we coincide with this angle. Then we translate and we coincide with H. So we know that D and H go together. Then they talk about E, and E is going to rotate to here, reflect to here, translate up to there. So you know that E and G go together. And then F would rotate around to here, reflect to there, and then translate up to there. So one really easy way to try to do these triangle congruent statements is to just match up like the colors, match up the corresponding angles. So if DEF is going blue, pink, green, then the other triangle needs to also be named blue, pink, green. So HGK in that order. And that'll do it. We know that's right. And now that we've got a triangle congruence statement that we know everything's in the right order, they're asking us about angle E, which falls in the middle. We know we could just give G, because it falls in the middle. And we could double check. It says E, that's pink, that goes with G. Both of those angles are obtuse is another thing we should be noticing. So of course the obtuse angle must pair up with the other obtuse angle, but we know it's G. And the reason those parts are congruent is because they're corresponding parts of congruent triangles. So they are obviously congruent. CPCTC, that's what that stands for. Corresponding parts of congruent triangles are congruent. Now they're asking us about DF, and DF is what? Blue-green, so it must be congruent to HK. Excuse my voice. HK by CPCTC. So that's it for that one. Whoops-a-daisy. You can't quite see that behind my face, but it says CPCTC. All right. So finally we get to the real sort of biggest part of the whole quiz, which is you guys are going to be given pairs of triangles. You'll be given some information about them. Other information you'll have to figure out for yourself. And then you have to decide if the triangles can be proven congruent or not. All right. So look in here. This one's kind of obvious because the given information is literally labeled for you already in the triangle. So we can see that AC is congruent to EC. Then we can also see that BC is labeled as being congruent to DC. But now we're running out of stuff, right? There's a few more things we could possibly try to prove. So I see an angle B and an angle D. Maybe those are congruent. I see an angle A and an E. I see these angles in the middle, ACB and ECD. And then there's the one pair of sides left that we haven't labeled, so maybe BADE. So every triangle has 6 pairs of parts, and I'm usually going to give you 2, and then you have to find a third. And all it ever takes is 3. Once you can find 3 pairs of congruent parts, you usually can prove that the triangles are congruent using one of our rules, either side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. One of those things ought to work. So out of these 4 things, they all seem to be congruent. And that's what you guys were doing in class. It was driving me nuts. You guys would just pick anything that looked congruent. But they all look congruent. So you can't just pick whatever you want. You have to have a reason. And we said in class there's really only 2 reasons that you can ever use, unless the information is given. Anything given you can use, but outside of things that are given, the only thing you can ever use are vertical angles and shared sides. So pretty much every single pair of triangles that I give you is either going to include intersecting lines that form vertical angles, so they might look like a little bow tie, like this, or they might look kind of like an hourglass, like this. But either way, you'll see pretty clearly intersecting lines where the angles across from each other, you can say that they're congruent. Or in this figure here, you've got angles across from each other, and you could say that they're congruent. The other thing, the shared side, is when you've got 2 triangles that have been put together. Maybe you've got a triangle like this, and then the other triangle shares that same side, and they fit together like this. Well, you can always say that that shared side is congruent to itself. You'll always be able to use that. You might have a parallelogram where they cut down the middle like this. Then those 2 triangles are sharing a side too. You could say those are congruent. Of those 2 options, vertical angles and shared sides, I hope you can see that we've got vertical angles right here. So the one piece of information we can get for ourselves is this one right here, the one about angle ACB and angle ECD. ACB, ECD, we can say they're congruent. We even have a reason why. We can prove it by vertical angles. That's the only thing you can use. So now that everything's plotted, you now have to pick which one of these works. It's obviously not side, 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 because we're not using all three pairs of sides. We're using two sides and an angle. The only thing that the only thing that has two sides and an angle is this one, side, angle, side. So you just want to make sure that this isn't ASS, because ASS doesn't even work. If you ever had triangles where the parts were oriented as ASS or SSA, then that doesn't even work, and you'd have to say that the triangles can't be proven congruent. You should also know that angle, angle, angle doesn't work either. So if you had a pair of triangles where the information that you knew was that all the angles were congruent, that too is not really enough information because it doesn't work. But this is side, angle, side, because we see that the angles that we're using really do fall right between the two sides that we're using. These are the sides we're using. This is the angle we're using. They fit together in side, angle, side. So finally, we can say, if we're talking about triangle ABC, ABC goes up and down like this. So that means the other triangle would be named up and down like that. It would be EDC. And they'd be congruent by side, angle, side. So now they're just asking us a question about, we're going to be using CP/CTC here. We know the triangles are congruent, and they're asking us about parts. So we'll say the corresponding parts of congruent triangles are congruent. And they're asking us about CED. So angle CED is this angle right here. So we can hopefully tell that that corresponds to this angle here. And that guy would be named CAB. And so finally there's everything. I talked about this problem for a long time. I won't do all of them this slowly. I'll do the other ones a little bit faster, so don't worry. Anyway, so here's one. Again, the first thing you're going to do is start with your given information, which we said there was a typo here. That should really be CB. And so if AB is congruent to CB, we'll mark that. Actually labeling the diagram is an important part of this. We'll write it in our list. AB is congruent to CB. And then we'll move on to the next given, which also has a typo. It should really be CD. And then it's AD, CD. We'll mark these with a double slash to show that they're congruent. We'll write it into our list. But we've run out of givens, so now we're back to that position where we're looking for something on our own. It's not going to be any of these angles. None of those angles are vertical angles. And again, if you go back, the only angles we can ever label as congruent are the vertical angles. So don't forget the other option we have is to look for shared sides. And if you look at these two triangles, they share a side. They share side BD. So we know that the next piece of information we can find for ourselves is to say that BD is congruent to BD. And that's by reflexive property. Okay? So we have all our information now. And looking at one triangle, I see a pair of sides, a pair of sides, a pair of sides. So this must be side, side, side. And the triangle is named BDA. So BDA starts here and comes down and out. So naming the other triangle, B goes with B, D goes with D, and A goes with C. So we'll go BDC, and that'll be the name. And then they're back to just asking us about corresponding parts. And frankly, we already knew that AD was congruent to CD. So this is easy. This is CP/CTC again. That's it. Moving on. Okay. So this one's a little tougher, because they're telling us EF bisects Angular D. For that, you have to remember what bisect means. And in geometry class, bisect means cut into two congruent parts. So you can bisect two different things. You can bisect a line segment. If you had a line segment and they told you that some line was bisecting it, then you would know that these two halves of the segment were congruent. But you can also bisect an angle. And you guys know that. You've actually constructed angle bisectors with your straight edges and compass. But if I told you you had an angle and some other line segment was bisecting it, then you would know that the two halves of the angle are congruent, right? So using that idea, we can come up to our triangles. It says angle RED is being bisected. RED is this guy. And if it's getting bisected by EF, then you'd be able to say that this angle right here is congruent to this angle right here. And we can build that into our list. So that's angle REF. and the other angle would be angle DEF. So that's giving us our first pair of congruent parts. Now, it also says that angle RFD is getting bisected by EF. So RFD is this angle over here, the smaller one, but he's getting bisected too, so you'd be able to say that this half is congruent to this half. And that's angle RFE congruent to DFE. Now again, we're out of information. You might want to say, if you've already got these angles, then you would say angle R is congruent to angle D, but again, nope, you can't do that. What are the only two things we can ever actually use? Vertical angles and shared sides. That's it. There's no way to say that these angles are congruent. Looking at this, I don't see vertical angles, but I do see another shared side. So that's what we are going to want to use here. Okay. Looking at these two triangles, they share side FE. So that's what we can say, is that FE is congruent to FE. That's our shared side. So labeling that, we now have our three pairs of congruent parts. And looking at this, I've got a pair of angles right here, a pair of angles right here, and then I have sides. And those sides are right between those two angles. So that's what ASA looks like. And to name the triangle, they said EDF. So EDF goes around like this. So angle E in the bottom corresponds with angle E on the top. So for the top triangle, would still want to start at E. Angle D in the middle, you guys hopefully can tell corresponds with R. So you want to name the other triangle in that order. You'd want to go ERF. And nothing else would be considered correct. It has to be ERF. But that's it. We found our corresponding parts. We named our triangle. We gave the reason as ASA. And now they're just going to ask us about a CPCTC thing again. They're saying, who's RF congruent to? Well, if RF is this guy, it's going to be congruent to this guy. Those are the corresponding parts. And if they're saying RF, you better say DF for the other part. And you got to remember the hat, and it's CPCTC. So that's it. That's number 6 down. We can move on to 7. Now for 7, it's a little weird. You've got one piece of information that's just labeled in the diagram, and that's angle ABD is congruent to CBD. But then you've got another given information that's written down up here, and it's not labeled in the diagram. So you're going to want to read that and label it for yourself. We're going angle A, double slash. We're going angle C, double slash. And then put that in your list. Alright, again, we have to find another piece of info, and I don't see vertical angles, so I hope I see a shared side, and I do. It's right here. It's BD again. So we can say BD is congruent to BD. So okay, I've got my stuff again, but this time what I see is a pair of angles and a pair of angles, but the side between those angles is this side here. If I was using this side, that would be ASA. And so we can see that the fact that the side that we're using is that green one over there in the middle, this one, that means we don't have ASA. What we have is AAS. That's a different orientation of parts. So hopefully you guys are clear on the difference between ASA and what we have in this triangle, which is AAS. But that's the reason, and that's one of our valid reasons. So now we just name the triangles. They said CBD, so they're starting here, going up to B and down. So maybe you can tell pretty easily. We would name the other triangle starting at A, up to B, down. It's going to be ABD. And that's the name you have to give. Everything else would be wrong. But there's your triangle congruence. Now it's saying who's congruent to AD. And again, you just find AD. It's this guy here. So AD corresponds to CD, this other part over here. So we can say AD is congruent to CD by CPCTC. So that's 7. I think now we get to a page that's like, yeah, there's just going to be 10 of these, right? So here's the first 2. I'm going to label them as number 1, number 2. On your paper, you might want to do this too. Then you got number 3 and 4. This will be 5 and 6, 7 and 8, and then you'll get to 9 and 10. And then that's going to be it. So starting with 1 and 2, again, I see my 2 pairs of congruent parts. They're already labeled for me. The only new thing I can get is this pair of vertical angles. So yes, you should label them. We always label everything we know. But the deal here is I have angle, angle, angle. And we said angle, angle, angle is one of those shortcuts that doesn't actually work. So who's this triangle congruent to? Nobody. You should probably say something like not applicable and then explain the triangles can't be proven to be congruent. And if I know you guys, you're not going to want to write all that out, I'm sure. So CBD as an abbreviation, that wouldn't be bad. Cannot be determined. It cannot be determined whether they are congruent or not. So if you just want to say CBD, that's fine. Okay. But again, why? Why can't we do it? Well, because we've got angle, angle, angle. That's not one of our valid excuse me, shortcuts. So just to remind you of all the options, there's side, 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 angle, side, angle, side, angle, 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 side, which is the same as side, angle, angle. We even have our new shortcut that we learned today in class called HL. Those all work, but those are the only rules that work. Angle, 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 and side, side, angle, which is the same as angle, side, side. Neither of those work. Those are bad news. Okay, so that's fine. Moving on. Let's take a look at number 2. This symbol here is the symbol for perpendicular. So they're saying BD is perpendicular to AC. That means we get a right angle here. But the other side would have to be a right angle too, which means we can say that those 2 angles are congruent. We can take that for granted. Now it says D is the midpoint of AC. If this point is the midpoint, then it's right in the middle of AC, which means it cuts AC in half. So that means we can now treat AD and CD like they're congruent by the definition of midpoint. Then finally, we do see another shared side. In number 1, we had vertical angles, but in number 2, we've got a shared side. It's right here. So we do have 3 pairs of congruent parts. We have sides, angles, and sides. So this is SAS. And again, they named this ABD, so they're kind of going up and down like this. So to name the other triangle, we'll also follow that same sort of naming pattern. If they said ABD, we better say CBD. And that's it for number 2. So for number 3, we've got a pair of congruent parts that's labeled for us. Then BD bisects AC, that's something new. That's a different thing. It says BD bisects segment AC. Well, again, the word bisect means to cut in half or to cut into 2 congruent parts. So if AC is getting bisected, then AD must be congruent to CD, those 2 halves. Then hopefully you see, again, we've got another shared side running down the middle. So we can say that's congruent to itself. And now looking at this, I hope everyone notices that what we've got is a pair of sides, a pair of sides, a pair of sides. This is side, side, side. And if they're saying triangle ABD, then it's the same pattern we've sort of seen, I think, a second ago, right? They're starting on the outside, coming up to the middle, and then coming down. Exact same pattern here. We're going ABD, so the other one will be CBD again. All right. Moving on to number 4. There's no given information, like it doesn't say BD bisects AC, but we've got the given information here where they're telling us these 2 angles are congruent. Oh yeah, and this is missing a point. I'm sure this is trying to be point E, so just fix that. Now it also says these 2 sides are congruent, right here. And that's it. So I now have to find one last piece of information for myself, and I don't have shared sides, so I guess I'll be using these vertical angles here. We can say that those 2 angles are congruent. And now with this labeled, if you pick a triangle and look, then I see a pair of angles here. I see a pair of sides here, a pair of angles here. So this is either ASA or it's AAS. And hopefully you guys remember what I explained before. It would only be ASA if the side that we were using was literally down here between these two angles, right? This angle here, this angle here. The angle between them is this side. That's not the angle we're using, so we must not have ASA. We must have AAS. And we do. That's what we have, AAS. Which is the same as SAA. So if you were thinking it's SAA, that's fine too. Now, how have they named it? They said triangle ABC, so they're going boop. So the other guy would go in the same way. It would be EDC. And then that's it. That's 4. So just a few more of these to go. We went over 5. Most periods we got to 5. It says C is the midpoint of AD. So right away, if you know that C is the midpoint, then you can label the two chunks as being congruent. Now you've also got given information here where it says BC is congruent to EC. Then it says that ED is perpendicular to DC. That just means that D is a 90-degree angle. And if AB is congruent to AC, then A is a 90-degree angle. So looking at this now, I see a pair of angles, a pair of sides, and a pair of sides. So this actually looks like ASS to me, which is one of the rules we said doesn't work. But you have to remember there's that other option called HL. And HL is for hypotenuse leg. And hypotenuse leg is for exactly the situation here. If I have a right triangle, then I know this side that's across from that, it's not really just a plain old side, it's a hypotenuse. And then I know these two sides that form the right angle, it's not just a side, it's called a leg. And so anytime you've got that 90-degree angle, you should be thinking in the back of your mind that maybe what you have is HL, and HL works. And HL looks a heck of a lot like ASS. So when you have ASS, but the angle is 90 degrees, you need to remember that that's actually a different theorem called HL. And HL is fine. HL works. So use it. So now they said ABC. ABC goes bloop, 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 like that. So the other name for our triangle is going to go DEC, just like that, following the same pattern, or sort of the mirror image of that pattern. Start on the outside, go up, come in. Here we started on the outside, went up, came back in. So it'll be DEC. And that's it for 5. For number 6, we've got a couple of givens that you just have to read carefully. It says ABD. So starting at A to B to D, that's this angle here. And that one's congruent to BDC. So from B to D to C, that's this angle here. And those guys are congruent. Then it says ADB. Well, from A to D to B is this sort of obtuse angle here. Put a double slash on that. And CBD. So CBD is this angle here. So we now have 2 pairs of congruent angles. And what we know we can find now is we've got that same shared side running down the middle. So we can say BD. We actually have to say BD is congruent to DB. The order would be different. But these triangles are going to be congruent because of ASA. And then checking the order, they said ABC. Well, ABC is a typo, because if we went ABC, that's not even one of our triangles. So that's a typo. I apologize for that. We'll change it. They probably meant something like ABD. So ABD is going to go from here to here and down. So A pretty obviously corresponds with C. I think that's obvious. But angle B in this triangle corresponds to angle D in this triangle. So if they're going ABD, we actually got to start at C to D to B, sort of in that order. So this triangle has to be named CDB. If you want everything to be named in the right order. But that's it. That's the end of 6. We labeled the 2 givens. We used the shared side, and then we had ASA. Okay, So for 7, so something's labeled here. We've got a pair of sides that's labeled for us. But then everything else we have to use our givens. It says BD bisects angle CDA. CDA is this bottom angle. So I know that that guy's getting bisected. Now it doesn't say that the upper angle is bisected. It just says only the bottom. So you can't go labeling these angles as congruent because it doesn't say that angle is getting bisected. It only says the bottom angle is getting bisected. But we do have this information here, this obvious information that says A and C are congruent. So you can mark those. And that gives you your 3 pairs of congruent parts. And looking at it, you got an angle, and the side that you're using is right between those angles. So that's definitely angle, side angle. And then to name the thing, they said ABD. So they're going middle and down. So we're going to go into the middle and down. So CBD again. This is getting boring with all the CBDs. I'm going to have to change this for next year. Not everything can be ABC. We got to keep this. You got to keep you kids guessing. All right, looking at 8, I see angles that are already marked for me. I see sides that are already marked for me. And then the only other thing I know I can mark for myself, since I don't see vertical angles, is I do see a shared side running down the middle. So I can use that. But looking at this, that gives me ASS. And since this is ASS, we need to actually say that these can't be proven congruent. So this here, what triangle is congruent? You'll say not applicable, and you'll give me a CBD. This actually cannot be determined whether these triangles are congruent or not, because ASS doesn't work. So looking at 9, you've got 1 pair of congruent parts just given right to you, so you can use those angles. Then it says AE bisects BD. So if AE is bisecting segment BD, then segment BD is the one getting chopped up. So BC would be congruent to DC. Then lastly, I see a pair of vertical angles. So that's what I'm going to have to use. I can grab these angles here, mark them with 2 slashes. That's going to give me my 3 pairs of congruent parts, and I see angle, side, angle here again. Angle, side, angle. And so now they're saying ABC. Let me guess. ABC go like this. So the other one would be EDC like this. Okay. So we've got one last triangle. And in this triangle, they're showing us that these sides are congruent. They're showing us that these angles are congruent. And then they've got one more piece of info. It says D is the midpoint of AC, which we've seen that before. If D is the midpoint of AC, then I can label these 2 parts as congruent. Then the problem is, if I have only this information, then this looks like ASS. So I'm not sure what they had in mind here, but hopefully you guys understand that even though these angles are marked with just curves, actually these angles have to be 90 degrees each. Because if they're congruent and they add up to 180, well, they'd have to be 90 and 90 to add up to 180 since they form a straight line. So since those are right angles, this side here isn't just a side, it's a hypotenuse. This side isn't just a side, it's a leg. So I think really for this problem we should be saying HL. And if they say ABD, it's that same pattern we've been doing over and over again. They're going from A to B to D. So we're going to go from C to B to D. And that's it. Alright. So if you guys watch this video and if you understand this review guide, then the only other thing now is go over your homework. Look over a few homework problems to make sure you really understand everything. And then you should be good to go on Monday. Alright. I'll see you guys then. Good luck.